Hi, welcome to the Olympiad geometry. Let's continue our study on the Menelaus theorem. This is a problem here. BC is diameter of a semicircle. The triangle ABC intersects the semicircle on point DE. D is on AB and E is on AC. FG are on BC, and DF is perpendicular with BC, and EG is perpendicular with BC. DGEF intersects on point M. Proof AM is perpendicular with BC, which means we want to prove that AM is in parallel with DF and EG. So we can just extend the AM, intersect BC on point H. Basically, we want to prove AH in parallel with DF in parallel with EG. So what we can get from the condition that DF in parallel with EG, we got the angle FDG equals to angle EGD, and angle DFE equals to angle FEG, right? This one equals to this one equals to this one. So triangle DMF is similar to triangle GME, which means we know the ratio that dm to mg equals to mf to me equals to df to eg. So assume that AM is perpendicular with BC, which means MH is in parallel with DF. So we got DM to MG, that must be equals to FH to HG, which means we want to find the ratio of FH to HG. So we have to have a term that includes the FH and HG. We can see that if we use Menelaus theorem on the triangle ABH and the line DMG, we have AD divided by DB times BG divided by GH times HM divided by MA equals to 1. Right? AD divided by DB times BG divided by GH times HM divided by MA equals to 1. That's on the triangle ABH and the line DMG. We can also use Menelaus theorem on the triangle ACH and the line EMF. Then we can get FH in the equation. And the line EMF. So we have AE divided by EC times CF divided by FH times HM divided by MA equals to 1. Right, this is the first equation. This is second equation. We use the first equation divided by the second equation. We got, because why we want to divide them? Because we can cancel the term HM to MA. So we have AD divided by DB times BG divided by GH times EC divided by AE times FH divided by CF equals to 1. And because we want to find the ratio of FH to GH, so we put them together and we can rewrite this equation to be AD divided by DB times BG divided by AE times EC divided by CF times FH divided by GH equals to 1. So we want to find FH to GH ratio. Then we need to find the ratio of these three terms production. So we want to simplify it. Let's look at it. We have AD here, DB here, and we have BG, we have AE, and we have EC, and we have CF. We know that we still have a condition we haven't used yet, which is that BC is diameter of semicircle. That means the angle BDC is 90 degrees, and the angle BEC is 90 degrees. Since angle BEC equals to 90 degrees and BDC equals to 90 degrees, we can easily prove that triangle BEC is similar to BEC, right? BEC is similar to triangle EGC and similar to triangle BGE. We don't know whether it's useful or not. We just write it down. Find whatever the conditions we can find. And for the angle BDC equals to 90 degrees, that means we can find BDC is similar to triangle, let's see, BDC, right? So we start from the segment of this one, so DF, that's DFC, and also similar to the triangle BDC, similar to this one, also similar to this one, and BDC, so BFD. Also, because this is 90 degrees, this is 90 degrees, so we have triangle ADC is similar to triangle AEB. From ADC to similar to AEB, we find the ratio of AD to AE, right? AD to AE equals to DC to BE. So we can rewrite this equation, which becomes to DC divided by BE times BG divided by DB times EC divided by CF times FH divided by GH equals to 1. Now we look at it again. We have DC here. We have DC divided by DB. DC divided by DB. We know that that's in the triangle BDC, right? So we have DC divided by DB. And we have the term of CF, right? So we take these three together, that DC divided by DB times 1 over CF, right? DC divided by BD, that's this angle, so it equals to we have CF here, so that's actually here. So we can see DC divided by DB, that must be equal to CF divided by DF, right? So this can be rewritten as CF divided by DF times C 1 over CF. So that means it's 1 over DF. Right? So we have this term, and this term. And we have another 3 left, which means BG divided by BE times EC. And if we look at this one, BG divided by BE and times EC, right? So B is here, EC is here, BG is here. So BG divided by BE equals to EG divided by EC, which means BG divided by BE times EC equals to EG. So then we have the production of these 3 terms turns out to be EG divided by DF times FH divided by GH equals to 1, right? We rewrite this equation to be this equation because these 3 term production to be the 1 over DF, this 3 term production turns out to be the EG. So it becomes EG divided by DF times FH divided by GH equals to 1. So FH divided by GH equals to DF divided by EG. Now we look at it. FH divided by HG equals to DF divided by EG. We know that DF divided by EG equals to DM divided by MG, right? So FH divided by GH equals to DM divided by MG, which means MH is in parallel with DF. So AM is perpendicular with BC. This problem is not that easy. At very first, we need to think about how to prove that AM is perpendicular with BC. Because we already have 2 lines are perpendicular with BC, so we just need to prove that AM is in parallel with these 2 lines. And because of the in parallel line DFEG, we can have some ratios as known condition, which means we want to find the ratio of FH to HG. Then we can use Menelaus theorem to make the segment FH and HG to be appeared in the equation. And then we use these 2 equations to find the ratio of FH to HG to prove it equals to DM to MG, where we can prove that MH is in parallel with DF, so AM is perpendicular with BC. I hope you like this problem. See you in next video. Thank you.